Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. Well, gentlemen, here we are again. Now, I need you all to just bear with me. I shot this video stretched out over an 8-month, maybe 6-month time frame. 3 or 4 different cameras were used, so therefore the sound level is going to be a little bit up and down, but I'm going to do my best to match it. I apologize. We're going to do everything we can to get it even. There is a little bit of overlap in the storytelling as I go through it. I'm not going to take those parts out. This is going to be a very long video, by the way. And I just think the story is worth telling and going over thoroughly, top to bottom. So, on that note, I want you to sit back, prop your feet up, get out the shots of vodka, or whatever it is that you decide to drink, and turn this into a drinking game. Because I swear, if you take a shot every single time I say throughout this entire video, this is not a ultimate high voltage, high output 3000. This is a low voltage, and then explain why I'm doing this project. You'll be drunk by the time you get to the end of the video. So, bear with me. Here we go. I think you guys are going to enjoy the end result. Well, gentlemen, here we go. We're going to do ourselves another huge major project. You're like, uh-oh. BBI, we remember this wizard. This is the 2-part wizard that we did for Mr. J about a year ago. It never made it to make the story short but long. We had this thing packaged by a company that, yeah, we got it all worked out at this point, but it took us 6 months just to get the insurance claim paid out on this. It got destroyed. I mean, like, they beat the ever-living schnikes right out of this box. A whole bunch of stuff got smashed on the inside of the cabinet. As I was telling my guy, Mr. J, I said, dude, don't worry. We'll get an insurance claim on it, we'll get it settled, and then we'll come back, we'll revisit this, and we'll make it better. The power supply cabinet itself, that deck is not too overly effed up. I can fix that very easily. But in our conversations, me and him, we came to a realization between the two of us. And the realization was this. The tube that is in this thing is stupid expensive. It's a 3cx1500a7. And it's an iMac. They're not making any more of those. So we took the insurance claim money and we decided to do something different with it. We're going to repair this, yes, fully, yes. Without a doubt, yes. But what we're going to do with it is different than what you think. I guarantee. I've been wanting to do this for a while. Really have been. People don't get it. I'm so busy over here that, whoa, hey, now where are you going, tripod? Okay, we're not talking about my 3-legged dog neither. I'm so busy over here that once I committed to doing this and it not being a repair, the repair I probably could have gotten done within just a week or two. I don't know if you guys have ever seen what an actual brand new 3000 looks like. This is what they look like. This is how they come. I personally picked this one up at a Conco myself when I was in Woodland, California, and they were kind enough to spend an entire day with me giving me a tour and showing me around the joint. I got lucky. Those guys are really super nice, very inviting, very friendly. It was an incredibly educational experience. I was so looking forward on that trip to being able to sit down, and I had it all set up to where, I drug all my video equipment with me all the way down there. At the last minute, corporate said no, they weren't going to let me video. But I was able to sit down and sit with one of their head engineers down there and really talk tube. This is a brand new, 100% new, directly from them, hand carried to Idaho by BBI, 3cx3000a7. Look at that, look at how pretty that is. So, we're going to do a little comparison here. Which do you think, which out of these two tubes can you literally buy two of for the price of one? I'm serious now. So, I got to talking with my buddy Jay, and I said, listen, man, because he's like, do you know where I can get any more of these tubes? Now I was like, Mr. Jay, that we know that this tube's tested. I showed this on video, this tube making stupid, ridiculous power. Okay? Actually, I remember the tube looking a little different, but this tube tested out strong, this little guy. He says, yeah, but I want to get another one. Well, it's a crapshoot, and it depends on who you ask. I mean, I ask these guys, well, have you had any problems with the Chinese tubes? Some guys say yes, some guys say no. So I can't really say, oh yeah, go buy this one from this guy, and I can't do that. The only thing I can guarantee or put my name on is going to be new. Okay? So, this tube here, new, if you go and buy them from Richardson's, is anywhere, the last time I checked it was $17.50. Now we're not talking eBay prices, guys. We're talking legit, shows up in an iMac box directly from Richardson's, which is the only company left that sells these, because they went and they bought all of iMac stock. They're it. That's who you've got to deal with. Unless you've got the inside track at Penna Labs, I think that, no, I think Penna's still independent, but there's no other importers left in the United States. RF Parts buys their tubes from Penna, and then they have their stuff printed on them. So you got Penna, Richardson's, and a Conco. Conco rebuilds tubes. Penna Labs. Richardson's is the only one that's got a Conco products. Okay, the American gold standard of tube. So, a Conco has a division. Okay, iMac is owned by this huge conglomerate corp that also owns part of Raytheon, and they own a whole bunch of different electronic companies. But one of the things that they own is a Conco. A Conco is iMac. iMac is a Conco. They're basically interchangeable. A Conco is off doing other stuff. They've got a huge antenna research division, and they're focusing most of their energy these days on government contracts, learning how to talk to aliens in deep space. I don't know. I am not that expert. I'm just a guy in Idaho that works on this stuff. The guys at a Conco, which is iMac, they rebuild these. Now, after I've been through their factory, and they showed me every step of the process, I got to meet there's one gal. I believe her name is Susie or Sally. I can't remember. This is almost a year ago now. There's one gal that builds these for all of us. She literally puts the guts together. She rebuilds from the stem up. Then there's a bunch of other people that are involved with the actual assembly of this, but the internal structure that makes this happen has been done by one gal. She got introduced to me as, well, she's the one that built your 3000s that you're buying today. This is 1700 doll hairs for this little guy, new. Or 800 some dollars for this. So Mr. J, I said, man, because you know he's pushing this tube for everything it's going to get out of it. I mean, you're really asking a lot from this tube. That, and it's got a warm-up time, and the internal structure of this tube is great. For the way some of us use these things, this is a horribly designed tube. The 1200, which has roughly the same anode on it as this guy here. This is a 3cx1500a7. The D7 is the one everybody really likes. This tube here actually outperforms by 1.5 miles any day of the week this guy. And in theory, this tube is smaller. This is a 1200, this is a 1500. The reason it outperforms is the internal structure of the tube is bigger, and the anode has vast more surface area. And they produce roughly the same amount of power. So a lot of guys for a lot of years were buying these tubes and they're loving the holy bejesus out of them. These are not rebuildable. That's not a rebuildable tube. So that means eventually someday we're not going to have these anymore to work on, or to have, or to use, unless we're willing to go embrace the Chinesium. My customer does not want to embrace the Chinesium at all. He says, "Zero China schmoo" upon his forehead. I said, okay. I said, well, I happen to have sitting here, because I bought, we'll just say a few. I bought a couple 15s. I bought some tubes while I was there. I made it worth their time to give me the tour, is what it was. And I was grateful for it, because I learned so much. And there's a big difference between watching on video and literally watching them run the tubes through the hydrogen furnace that's got the epoxy, which is a powder that they put on the porcelain, running the tubes in the assembly machine and watching it come out the other side, and then walking me across all, okay, so then now we're going to take and we're going to get the getters, we're going to fire the getters up, and we're going to cook them for X amount of hours. Way different perspective now I have on what's going on the inside of these things. Okay, a lot of love and energy goes into each one of these tubes. So I got another one sitting here. Let's do this. Let's take you away from this little weak tube, which it's not a bad tube. It's just stupid expensive to support. If this tube goes bad, you're out $1,600. This tube goes bad, he's out the tube, which they're going to ask for back as a core, and $800, and he's got a lot more headroom. The anode structure on this tube is vastly superior to this little guy. But believe it or not, they're pretty close to about the same amount of CFM. Okay, there's a lot of parts that are in this deck. The amp deck that got completely butthole smashed that we can take out and save, and we'll transfer to this tube. So I called my friend Chris at rfjunk.com. It's amazing how often I get to say his name, right? Between the freaking badass anode caps that fit on everything and this decent aftermarket tube socket. I got myself a tube socket, a bias board. I've got a filament transformer floating around here someplace. I know for sure that we can put in this box. He's going to have a whole lot more operation room with this tube pulling the same amount of current. So same voltage, same current consumption, different filament transformer than this tube will ever give him. Way more life. Like this tube, if the way he's running it with the power supply that we're going to build him, will literally last him until he's probably dead and his kids are dead. Think about that for a hot minute. Let that sink in. I'm going to button this all up. When we get back, I want to talk about the transformer for a second. Okay, let's talk about the reason we're actually able to get away with this. No, let's dispel some ideas that are already sinking into people's heads. Oh my God, so if I go to Wizard, 3cx 1500 box, I can just drop a 3000 in it? No. It's going to require a lot of modifications, but the reason we can get away with it is because of this little guy. Okay, so let's zoom on in here for a hot minute. This is made by MagCap Engineering LLC. There's their phone number and all their contact information. There's the part information, and we're going to look at the primary side, which is this side that's facing towards us. This is winding number 1, so 1 and 2. That's this winding, primary. Here's our secondary, 1, 2. Now, there's two ways you can wire this. You can wire at 110, and you'll get your 200 or 2,400 volts DC or AC out the other side. Or you can wire at 220, or you can wire at dual 110. Either way, which dual 110 is what? Say it with me. Say it with me. 220. Okay. I'm going to put this 50 up here for a sense of scale. This plate transformer is a beast. It's 1 amp. And it's also CCS rated. Now, I am not an expert on Wizard amps. Never claimed to be, never want to be. Wizard's still around. You got a question about Wizard amps? Call Wizard. Wizard is a smart guy, builds a great amplifier. Have absolutely nothing negative to say about him. I ended up owning this one because, well, I repaired it because the electrolytic blew out in it. And then we modernized the power supply a little bit, just added some safety interlocks to it, which I did have a full conversation with Wizard about on the phone before I went ahead and did this, and it got damaged. But now we're here, we have this big bastard. Where I'm going in this big train of thought is I'm not an expert on what he puts in all of his amplifiers for power supplies. None of my business. I'm sure that there's multiple different levels to it, just like it is with my business. So now, guys, I don't know if you know this or not, builders are really sensitive. A lot of them are. You have to be very careful. Someone like me, who's a repair center, who has a huge market share of audience versus everybody else as far as that are in the amp building community. And I have always prided myself on never belittling, tearing down, making anybody look dumb, or saying anything negative about anybody. It's not my job. My job is just to repair the boxes. And I've stuck true to that. Now, me being me, also recognize that amp builders are very sensitive. And if you mention their name with the wrong context attached to it, and I'm not talking about Wizard in any way, shape, or form, so don't get yourselves confused, and don't be getting out your I'm going to text Wizard, you're not going to believe what BBI said phone thumbs. Don't do it. None of that's taking place here. We're going to capitalize on this transformer that happened to be provided with this 1500. This transformer is bad A. It's big, it's heavy, it's strong, it's made of real iron. And we're going to take this 240 volts or AC that comes out of it. We're going to rectify it, and we're going to get about 3,300 volts DC out on the other side. The exact same thing that we were getting on the 1500, but because there's more plate dissipation, more tube dissipation, more, we're going to see a slightly more output power. The only major advantage is we're not going to be, it's a disadvantage, we're not going to be able to utilize the full output potential of the 3000 because it's not going to have enough plate voltage on it. But now my buddy Jay, the way he wants to run it is he's just going to hit it with a couple hundred watts, and he's going to get out of it what he's going to get out of it, which I bet will be somewhere around 3,500 to 4,000 watts peak, 1,500-ish bird. There's enough plate voltage here to do that, but there's enough iron here. This little rating at 1 amp. Okay. Now we all know the 3cx3000a7. It wants to have 4,000, almost 5,000 volts on the anode. I like to see them a little bit stiffer than that, closer to the 6,000 volt range. So when you fully load the power supply, underneath the full amp and a half worth of draw, it's going to drop down to the 4900, 4800 volts. Not it rests at 48, 4900 volts, because once you load the tube out all the way, it's going to drop on its face and it'll fall down and it'll be down around like 4200 volts. This is not the optimum transformer for building a full chooch, balls out, full bag of dicks 3000, but the tube, the 3000, is cheaper than the 1500, and we can take the same power supply, hook it up to that 3000 and loaf it along. So once again, I want to stress this the most, because if Wizard calls me and says, oh my God, one of my buddies called me and he said that you said that the booger's on the, I'm going to say, dude, have you watched the video? Dude, have you watched the video? Not that Wizard's ever done that, because he hasn't. Me and him have a good working relationship, and he's a good guy. I have had some other builders do that to me, where I've had to come along and correct some catastrophic things, and they don't want to call me on the phone. They'll try and confront me via text, which never works out well. It just doesn't. So guys, don't perpetuate the problem, because there is no problem here to be had. It's really simple. The thing got repaired here, got damaged in shipping, it came back here, and now we're going to up modify it, which no one here has said a negative thing about Wizard, and I don't want anybody to be confused about that, because we are not saying anything negative about him at all, and the only thing you guys have heard me say is positive things. So, you little wordsmiths with your texty thumbs, don't cause problems, because the only one that's going to look stupid is your butt. Just saying. Just saying. All right, moving forward. Transformer issue addressed. Big hunk of iron. You can run a 3000 on a smaller transformer than this, by the way. They make transformers that are roughly the same parameters. They're about way smaller than this, but I'm a big fan of big iron. So that's what made me moisten the boy shorts when I said, hey, how about we get you off the little piddly 1500 tube. Let's get you on an American iMac 3000, and you can be done worrying about all this horse malarkey. So, on that note, we're going to proceed forward. I'm going to get organized. I got to take an inventory of parts, and I'm going to start assembling our new RF deck. Guys over at Charger hooked me up with this deck almost a year ago. So I can make sure I still got all the pieces and parts for it. We're going to start moving forward, guys. My rant is over. Remember, don't be stupid and start texting. The only person that's going to look dumb is you if you try to start a war. Okay. I just rewatched my last little segment to make sure I had my diatribe right, and a little up on my soapbox. I said some things wrong. This has two primary windings. 1 and 2, which is up here. 1 and 2. Okay, 1 and 2. This is our primary winding, and then this is our second primary winding, and I referred to it as the secondary winding. The secondary winding is over here, you guys. It's on the back side of this transformer. Over here. Okay. A voltage go in and then come out. And the reason I got to clarify this, and be very specific about this and not be melodramatic or try and add flair to this, is that there will be somebody out there that says, oh my God, he doesn't know the difference between primary and secondary, and they will attempt to call me and correct me and say, dude, you do understand. And I will have to laugh and be like, well, yeah, I was just talking fast and shit comes out my ass, and I just, So, listen. When we tie the two primary windings together, okay, this 110 volt, this 110 volt, if we utilize ports 1 and ports 4 of the primary input side of the transformer, okay, the source side, the secondary, which is our output side, will produce this many voltages. It's that simple. Wanted to clarify that. Period. Full stop, nothing else to add to it. I fully understand this is the primary side and this is the secondary side. Just want to clarify that. Okay, now I can move forward and we can start building sexy, fun stuff. That's our interior wall. This is our floor plate. This is our side plates. This is our exterior wall, our top and our bottom. These are our sides. So, let's say I got all the parts. So now I have to make the decision. How much of this old box do I want to reuse? That's the $64 million question. How much of the old amp do I want to reuse? The old amp wasn't like necessarily completely 100% stamped out purpose built for what it is. It's not. It's snot. Snot. Never was. This is literally like the last one of these they had on the shelf at the time. This box. I felt very lucky to get it because I thought I would get here a lot quicker, and I did. This has been a very drawn out process getting this far. I'm here to tell you. To the point where Jay's like, man, seriously, like, how much longer is this going to take? And I'm like, dude, however long it takes. And I mean that with all seriousness in my heart. I'm done getting in a rush, you guys. I'm done hurrying, and I'm done caring about me hurrying. So calling me and harassing me and bugging me and trying to get me to do things faster, I will literally just send you back your shit. I'm over it. I've only got one speed, which is not fast. So. This is our socket. This is our high voltage resistor. I mean, I'm going to reuse a lot of this stuff. Like, plate choke is perfectly acceptable. Our bypass cap's completely acceptable. A little bit of cleaning up and rebending, I can get this vac cap to work. Since we're not going for the full chooch, full shebang, knock down, drag out, full up output, we can still use this cap. Although I'm pretty sure that I got a vacuum variable around here I bought just for this. Pretty sure. High voltage pass-through's okay. The blower's okay. The front end of the cabinet's what's the most bunged up in the lid. And of course, I'm gonna go with a ceiling mounted chimney because it's me. I have taken the bottom off. The bottom's all full of yummy little parts too. Here's our filament transformer. There's our bias supply, I do believe. And so these tuners are more than acceptable to work on a 3000. It needs all new switches, which I've got some cool ones with rockers, airplane rockers on them, like rocket ship click down rockers, rocker covers that I'm going to put on this thing for him. I never did like the big long paddle switches that got ripped off that were on the front. I gotta think. I am not gonna lie to you, none whatsoever. It's looking a little bare inside this cabinet. I spent a little bit of time this weekend, like a good portion of a day, sitting down figuring out what I wanted to do here and how I wanted to modify this thing. Now, I could have simply replaced this front skin, the front side of this amp, re-drilled my holes, replaced the power switches, reutilized this hookup plate in the back, removed this socket, and cut out a new piece of aluminum and stuck it in here. It would have been a lot less work, but it wouldn't have been built the way I wanted to build it. Does it make any sense to you guys? I hope that does. So instead, I went this route over here. This is every piece of this amp that I'm going to reuse. I might, depending on what parts I have sitting here, come back here in a little bit and take out of the deck the 12 volt power supply, unregulated 12 volt power supply that's in there to run the relays and to well, run relays and run LEDs, indicator LEDs and stuff, but probably not. Tank coil is good. Our knockdown resistor for our meter is good. Our pass-through high voltage connection, Molex connectors are good. Our vacuum cap is good. I want to plan for the future here. So I don't know if I'm going to reuse this tuner or not. I have several vacuum tuners here that I will probably end up swapping out this for a vac tuner close to that. That's a Russian vacuum tuner here. Well, Jennings made some like this as well, but taking into account it's scribbled with Cyrillic that tells me it's Russian. So, but yeah, we're going to reuse these two tuners over here for our PyL input network for the 3000. This is really slick because if we wanted to, I mean, like if I wanted to in the future, this guy, my customer, Mr. J, he could call up like EPD and say, hey, Peter, Michelle at Electronic Product Design, Tony, you guys down there, I need a transformer to fit in these dimensions. It's got to run off 220 on the primary, and on the secondary I've got to have like 4,500 volts and 5,500 volts on the secondary with a 0, and switch out transformers and be able to just have a monster of a 3000. So we're going to work towards that, but we're going to work with the transformer that we've currently got, because he doesn't need that, you know, mythical 10,000 bird slammed in a corner 3000. That's not what he's looking for. The reason we're changing this tube out once again to stress to everybody why we're doing this is because the tube is $1,500. The 3cx1500a, okay, versus a 3000 is like $800. So when it's an American-made tube, got a little bit of cosmetic work we got to do on the blower. I think as low. Let's see, what is this thing here? 110 volt. Really, you're not going to give me your CFM rating? $2,880 CFM. It's a little low. Let's go over here to the confuser. Hold on a second. Let me double check some stuff here. I might need to go to a different blower. I had to double check. Oh, it's a 2,880 Ripem blower that produces 110 CFM, made by Dayton. This is on the low end of acceptable for maximum for air pressure at 10,000 feet behind an anode. According to the data sheet, and I'm reading it verbatim, so if we're going to try and dissipate 2,000 watts of power, the anode base is going to need 49 CFMs worth of airflow, and that's at sea level. And the anode itself at 2,000 watts worth of total dissipation, that's 2,000 watts carrier, by the way, which a 1500 couldn't really achieve and maintain, 71 CFMs. So we're 25 CFM above that at 10,000 feet elevation, and 50 CFM above that at sea level. At 3,000 watts of anode dissipation, okay, 85 CFM at the base, and we need 124 at the anode top. And that's this is in continuous operation, by the way, you guys. So that's at 10,000 feet, by the way, also. So at 4,000 watts continuous output power, we're going to need 127 CFM at sea level, or 185 CFM at 10,000 foot. This is roughly a 100 CFM blower. I'm going to go see if I've got a bigger one, because if I do, we're going to strap it to this son of a bitch, and we're going to make it make some frickin' air movement. Come on, expensive tripod. You got fluid dampening shocks in you, for God's sake. Look at it. Slowly drifting down. It's okay. I love this tripod. It's big, it's heavy, it's bulky. Not to mention I got like 9 different things strapped to the top of it now. You guys should see the production that has to go on to make these videos in 4K for you all. It's just silly. It's overwhelmingly silly. Yeah. We're sinking way more money into the production of the videos than what the videos actually themselves. And we're not taking into the total amount of money that we make from just the repair side. We're just talking just the YouTube ad revenue. Even though I got an incredibly busy channel, it's no money. It's literally no money. We started looking at our analytics the other night. We started getting a little depressed and sad. So I don't know. My wife's like, "You need to do a Patreon channel," and I was like, "No." She goes, "Why not?" I said, "I don't know, but no." I hate change, man. I hate change. Yeah. I'm gonna go look. I know I've got like 5 or 6 different blowers around here, and I want to make this top cooled. That's another thing. I gotta call ICA today and get one of their Teflon chimneys. You guys would be foolish if you don't use the Teflon chimneys from ICA. They're stupid cheap. They're like 80 or 100 bucks for a 3000, and they're perfect. I mean, they're just zip, 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 you're done. No zip ties, no. And here's the nice thing, is they're really thick. So those guys that are running the 15s and the 20s and you got to have a hose clamp around your shit, this thing literally slides right down around the tube, and it's so heavy the blower can't push it out of the way. Just saying, food for thought. Okay, I gotta run. I'll be back. Believe me, we're gonna be back. So you all that have watched me do this a couple times now know exactly what I'm doing here. So this is our, see, now I can't use that as a top piece. It's got a scratch on it. Let me flip it over. Okay. So those of you that are familiar with the 3000 building process and other large tube amplifiers, which have done your due diligence and have watched me do this before, know exactly what I'm doing. So we have to think dimensionally. Okay. This is an old beat up ProTech that I've had forever. It's a dud, straight up dud. Okay. When you twist this thing next to the microphone, you can hear it clinks like a slinky. Now, I was having a big discussion with another guy the other day, and I was having to explain to him, he's got a 3-tube amplifier. I'm not going to say what kind of tubes, because then you guys will start speculating on who. But he's got a 3-tube amplifier, and it's set up in a configuration where he's got one tube here, another tube here, and then another tube out here. Okay? So the 3 tubes are all packed real close together, but the one tube in the back corner, because man, I don't get it, I don't understand. It always pulls more current, and it seems like that tube's doing the bulk of the load. So he's got, and it's a weird shaped deck that he's got. So he's got one tube off in a corner, another one here, and like another one here. And I said, well, the one that's sitting out here by itself, which is closest to the wall of the deck and the back of the deck, is got a different amount of capacitance on it because of its proximity to the cabinet versus this one here and this one here. I was like, how do you figure? And I said, well, this one's only got proximity on the back side. Okay. Where this one's got proximity here, this space here, and then again here. And he goes, well, what can I put in there to make it so that it, you know, he goes, can I put Teflon in there? He was coming up with all these different ideas. And I said, no. I said, your option is this tube that's sitting here now has to have a false wall that comes off the floor up to the top of the anode to simulate its proximity, and then it has to have another plate that comes this direction to simulate the proximity to the back wall of this tube here. And then this tube that's sitting over here by itself, it needs to have a piece of metal here. That makes sense? To simulate the tube's proximity to the case. Different capacitance. Capacitance in its all its fanciest terms, no matter how you want to look at it, we are boiling it down for proximity to ground. And the term that we use is capacitance. It's the same thing here. Let's cover up the whole sensor. It's the same thing that's going on inside this vac tuner. So we'll screw the vac tuner so the bellows will compress. This is going to compress. And you see those fine little rings that are on the inside here? There's fine little rings that are down inside of that. This has got counter rings that slide inside of those. And what we're changing is our proximity to ground. It's the same thing that's happening here with this tuner. When we go and we move the fins, usually it's the bottom side. Top side's where your RF's going to be. What are you doing when you bring these fins and you interlace them like this? You're increasing the proximity to ground, or any other thing that you want to attach here, but 9 times out of 10 it's ground. Okay. So you're elevating its proximity to ground, but you're doing it in a controlled fashion. And he was having a hard time. He's like, no, man, I can put some Teflon or something in there. I was like, no, dude. It's the physical location of the tube and its proximity to the case. I built a 3000 one time where I put the tube way out here in the middle of the deck. I mean, from your angle, it's kind of set to the left. It's actually dead center down the deck. And I've covered this in several different videos. When the tube's out here in the middle of the deck, it's got nothing to react with. It doesn't like that. It doesn't like that. Like I said, I built the 3000. Had to call, get a new plate. Had to reattach everything to the base plate. But I put the tube over here in the corner. And that amp just took off. It wants to be about an inch, inch and a half away from the cabinet. It wants to have that proximity to the edge of the case. I mean, we could simulate this by measuring it and then getting ourselves a huge doorknob or a huge capacitor and going directly to ground, but we're going to set this off in the corner evenly, and we're going to start marking this case. So I just got off the phone with the customer, and he told me that he doesn't care. And the question that I had, one of the many questions I had for him in doing this is, how did he want to have the tube exhaust? Left corner, right corner, front left, back left, what? So he didn't care. I like to build the back left corner. So now, if we take our rule hair, and we measure in, this is a 1-inch ruler, by the way. Not 1 inch, it's 3/4 of an inch wide. 3/4 inch ruler, there's a little lip that's on the bottom of all 3000s. We measure that to the edge of the cabinet, 3 inches, and we come in here at a 90-degree angle to that, and we measure in 3 inches. I have discovered that is roughly 1.5 inches. That is roughly 1.5 inches. Now, I have done multiple videos. Let's talk about the Demon and the Exorcist videos for a hot minute. I've done very in-depth videos on how to build a 3cx3000a7 to its max chooch. Way over spec plate transformer, way over spec filament transformers. Three or four videos that are approximately 3 hours a piece, and literally step by step on how to go about doing those. I mean, I'm talking like, you see these kids today, they're building computers and they've got RGB lighting on everything. I literally threw everything but the kitchen sink. It had 2 parts from China out of both of those boxes, and that was the LED switch mode supplies that I used to run the fans, that kind of thing. And I had 2 parts that came from Japan, which were the tuners. Everything else was an American sourced component. Think about that for a hot minute. Cabinet, case, aluminum, all that shit American sourced. It's kind of hard to do. But I thoroughly covered this whole proximity capacitance thing. I do believe I've even measured it. I talk about the operational phenomenon, how it affects the tube. This got reinforced to me by teacher number 1, Prime, teacher number 2, Yellow Jacket, and Shock. They all talked about the proximity and the location of the tube inside the deck and how it drastically affects how the tube operates. So if you got any questions about that, please reference those videos. I'm not going to put the links below like every other YouTuber. You guys can go type in 3cx3000a7 BBI and you'll find them. I like this little template for this reason. It's like sniper crosshairs, man. Okay. Time to start drilling me some holes. Some holes, damn it. So now, note, lid has been marked. Right, left, back, front. That's really important. And this is marked inside, left, right, back, front. I have to think like this. So now, word to the wise. Teacher number 1 taught me this. He goes, there's no way. Because you can measure your ass off. There, Mr. BBI. Because the easiest way I've found to do it is thusly, and I'm going to show you. This is always where I start, because everything flows off of this. First, we punch this hole in the base deck. Then, see, left, left. Before you get carried away, you mark everything thoroughly, you measure this up, and the best way to transfer the center line of the tube to your exhaust hole is just like that. So going forward, when I punch my 3 in a whatever it is hole for the exhaust, out the lid, and because I'm going to mount my chimney to the lid, because we're going to do a pressurized deck, which is way more efficient in moving air around and way better at cooling off all the parts inside the deck than doing a bottom pressurized. Another one of those things I talked about. The top piece, the tube, the anode, all the ships at sea, and the parts and bits and pieces have to line up perfectly. And this is the end, so we have to measure out and mark in the beginning. This is another one that's really important that we don't F up, but we do it first. This is our input network, our Pi-L circuit. This is going to be our output relay. But we can come back to this. So, inputs marked, tubes marked. Let's put our guide away. It's precisely a 3-inch hole, by the way, based off of this. We're going to go out 1.5 inches in each direction. Okay, let's start prepping for that. Oh my God. Okay, so it's been like 4.5 hours since you and I spoke last. You and me. I went on a hunt. Now, I've got 3 boxes that are like this, but I could only find one. Now, this is the variable. This is a 10 through 500 puff, because it's written on it, because I tested it. 10 through 500 puff cap. This is one of the caps that came out of the amp. They were actually orientated like this. Okay. Now, that's a Russian vac cap. And I thought, man, I got another one of those. I've got another one of those. Where is it? I was like, man, it's on the shelf over here behind me. It took me 2.5 hours to dig through all the parts that I've got to find this particular box. I've got 2 more boxes just like this on that shelving unit. I can't find them. I found an additional 3500Z I didn't know I had, an additional 4-400, a 4-1000 that I didn't know I had. Found an extra 3000 I didn't know I had. Well, at some point or another, I knew I had them, just forgotten about them. Found all these other parts I went digging and diving and dumpster diving, and I found what I was looking for. And I was like, hallelujah. This is what I was looking for, was this particular cap. And I reached in that box like a freaking ninja. We all seen that movie, Bloodsport, where Jean-Claude Van Damme dives his hand. It's a movie about David Duke, this martial artist. He's training, he's a white guy, and he's training Japanese, diving, he's grabbing fish. They're pulling him out of the tank. And I darted in there and I grabbed the thing out. And I'm like, yes! Hallelujah! I started looking at it and I'm like, yes, yes, yes. Oh, no. Let's flip this to manual. No. This thing survived the Cold War. Got smuggled into the United States, probably in somebody's butt cheeks, to be used in radio. Made it all the way to Boise, Idaho. And because I didn't have enough packing material around it, because that was good when I bought it, it's now got a nice big old chip out of it. Now I know it's lost the vacuum, because if I shake it just right, there's the piece of glass that popped off the inside. It's okay. We have extra options. So, I got this beautiful girl here. This will do the job. This is 10 through 500 puff. Easily do the job. This one here, also do the job. This is a Jennings. See, they're both black. They're both pretty. Shiny copper. Get to the copter. Okay. This is, what is this? It's a 500 through 19. This one, 1900. This one won't work. This one would do the job adequately. Very adequately. And so would this beautiful Jennings right here. That's 10 through 190 puff. I could use this facing the tube, put this one on our output side. I've got boxes of these things. And I'm grateful that I do. It's like, I see it, I must have it, I don't know what I need it for yet, but I'll find a use for it. Here's another little vac cap that I got. I think I got this one from my business partner. We're going to ignore this strap. This is horseshit to me. This is not acceptable. The reason I had to dig this out, this is out of a different stock. These are what I call all of my small vac caps. Well, some of my small vac caps. I mean, I do this all day. Pull them out all day long. This would be, I consider to be a medium-sized vacuum capacitor, and it's all about the kVA rating. Come on, yeah. The reason I need to pull this out is because I'm going to use this cap right here. I'm going to use this mounting flange, which is the actual legit thing. See, this literally would fit on the back end of this cap without the shitty stainless steel strap, you know, pipe strap. We're going to use this fitting. We're going to slide it on the back of here. Now, here comes the other problem. We're going to talk about shaft size, boys and girls. The shaft size is important, and it's more important than what girls let you think. More important than what girls make you think. Give me a minute. I got to take this call. I gotta get away from my other job. I gotta start doing this full time. I must. I gotta find a way. Okay. So like we were saying, wrong value capacity. We'll put this out of the way. We can't use a fixed. Put that out of the way. This one's just about right, but we're going to talk about shaft size. Now, girls always try to tell you, they try to be nice to you boys, and they'll say, well, shaft size doesn't matter. Shaft size does matter, boys. Let me show you how it means. This knob fits, if I hold my tongue out right and I got the set screw out, will fit on this shaft. I want to make my knobs match. The knobs that come off of this stuff, this whole hardware, will not fit on this shaft. So what I had to get was this flexible decoupling joint. Now, I'm not going to say anything, but I'm pretty sure that I can take this joint here. Let's go to manual. There we go. Take this joint here on the inside, this little one here, which is actually big, downsize it to another piece of all thread, and we can build ourselves a little stand that might be pre-equipped on here. I'm not saying nothing yet. Then we can set this back from the cabinet a little bit, have this flex decoupler joint and a rod that comes out of front of this and goes to a knob. And it goes to a knob. But this is the right value cap that I need. Wrong shaft size. But I got to run off and go work at the other job. I'm only here 2 days a week. I think I can find out some way to get out of this. But I enjoy leaving the house every once in a while. I do. I enjoy leaving my shop. That's a lie. If I never had to leave here, I'd be perfectly happy. All right, away I go. I shall return. It's about enough to make a guy just want to sit down and cry. I just wiped my ass with like $300. Oh, man. Getting in a hurry, not paying attention. Let me show you what I did. I was getting ready to put this away, and I thought, man, shit. I'll pull this piece off of there real quick. It goes together like so, just like that. So I pulled this piece off, and this wasn't threaded all the way down in the shaft. And this popped off. It's held in place with this retaining collar. That sits on there like so. There's a washer with a bearing race and a head spacer. and this was sitting on top of that. And the bellows slammed down in and split this vacuum variable and shattered the glass. This was easily a $300+ piece that are almost impossible to get your hands on anymore. And then coming to find out, this downsizer decoupler won't fit. Joy, happy joy, happy joy. So I robbed the shaft off this broken vacuum cap, and then I was able to get it to work in here, same thread pitch size. Bearing chase is the same. This has a steep taper to it, this one does not. So next trick was making the knob actually fit. What I mean by that is, even these are the ones that were off the face of the amp. To make this fit originally, somebody else had to come in here and drill it out. So I just took a step from their playbook and I drilled this out a little bit. Now we got a fully functioning, appropriate vac cap. So now I need to go and get myself some of these standoffs, which I do believe are all thread line extenders or whatever the heck. So on the upside, the only thing I didn't manage to screw up today was this actually slid right on like it was supposed to. So we have that going for us. I'll save it just because there might be parts on it. I stripped that other vac cap completely down and threw it in the trash. So, okay. I've lost the enthusiasm for this project today, and I think you can understand why. God damn it. So where we left off in the last little segment was me pissing and moaning about breaking a vac cap. Well, that was about a month and a half ago, and I've been working on this in my spare time. Since that last video segment and this video segment, there's been about 5 other boxes that have been repaired, 6 other boxes have been repaired and left here. But I've been working on this steadily in my own free time. So we've now fully assembled our amp deck. Well, we're about 80% done. So I wanted to bring you up to speed, and I just dawned on me the other day. I'm like, dude, you're cruising right along on this thing, and you need to stop and take video so people can understand what you're doing. Here we are, okay? Let me bring you up to speed. Now, that is our amp deck, where we sit today. Now, I'm not going to dig that out. I'll get that out in the next segment. Let's just grab the mock-up tube. So, this is our dented anode ProTech, which is junk. This thing, it sounds like a baby rattle on the inside. This thing's garbage, okay? And I use this just for mock-up. Now, I've been, like I said, steadily working away on this thing. And I forgot to shoot segments as we've been going along. When we cut away last, we had a bare metal pan and me talking about vacuum caps, okay? Let's go up in here and let's take a look for what we got going on now. So as we can clearly see, our vacuum cap over here is in, our vacuum cap's in here, our tank coil's in place, our blockers are in place, our strap for our 3000's in place, our secondary voltmeter, because remember there's 2, because this is a split unit, and for safety we have to have 2. 1 in the power supply and actually 1 on the amp deck. Tank or plate choke is in here. I got a glitch choke I got to throw in over here yet. Our relay's in, our coax connector's in. Our blower is in. Let's turn this around. So our 2 coax connectors, one's here, the other one's up underneath this blower. Our high voltage lead is in. That's off-centered for a reason, and it's because of placement on the inside of the deck. We created our little seal gasket around our blower motor. We've tested our blower motor. We've got, what is it, 300 and something CFM coming out of the tube, out of the top. Our filament hookup is down here. The only thing I have left to hook up is our operate on, our blower on. The filament is going to be controlled from the power supply portion of the box. So I'm thinking about making this almost a switchless box. You turn the amp on, everything else comes on auto. Blower, filament, all that stuff. Eliminate most of the switches. So I got to hook up our foot pedal, still yet to go. But let's talk about our lid. I went ahead and I got our chimney all mounted up. Here's our chimney. Now I've discussed in many videos why this is an advantage. Because now we get to cool all the parts inside the box. Our little tank coil, everything gets to get air on it now. And it all ends up getting shuffled around, tumbling around the inside of the cabinet and then blowing up through the tube. We all know why that's a better way of cooling versus having this sitting static with stagnant air on it and then under pressurizing or pressurizing the bottom side of the tube and this venting in. This is a direct exhaust out. So we're about 80% there on the amp deck. We've got a couple little small details to work out yet, but it's come time now where I've got all these other huge major projects done for me to go and populate the bottom side of this box. Our tuners are installed, our vac tuners are installed, our secondary voltmeter is installed, and it's just time. It's time for me to start putting more attention to this and that, and I want to get these big giant cabinets out of here because they've been sitting over there taking up the corner of this room now for, well, forever and more. Remember, our overall goal here is not absolute amount of power out of the 3000. It is mind-numbing to me, this statistical fact. Let me share this with you. Hold on, I gotta prep for this. Doctor. This is a rare fauna these days. This is an iMac 3cx1500a7. That this tube would become so expensive that it's not even cost effective to replace it, and it's actually cheaper by an order of about $800 versus getting a replacement brand new one of those to convert the whole amplifier over to this. Believe it or not. This is like 10 times the tube this little guy could ever dream of being. So we're going to technically clip the nuts of this tube. I think I've explained this before in the previous video segments, but it's been so long since I shot the previous segments. I'm sure just repeating myself, and you guys are like, get on with it, quit talking so much. Do it. This is a brand new, directly from a Conco, rebuilt 3cx3000a7. Now in theory, this is a 1500, this is a 3000. The difference is this on a good day can maybe do 4,000 watts if you hit it really hard, versus this with the right plate bolts on it, you can get it to do 10,000 bird. We're never going to achieve that with this power supply. Never in a million years is this going to happen. This right here is going to become a slow cruiser. Homeboy is going to be able to hit this with like a 2-pill or a 4-pill, and it just cruise. The power supply is big enough to handle running this tube, but the plate volts aren't high enough. So we're going to be like 4,500 volts or something, which is 1,000 or so volts low on this deal. No big deal. That's not what we're after. He wanted, when his box got smashed, he wanted us to be able to go and replace this with something that could, 1, be rebuilt, and 2, was still available. That's the smallest tube that they rebuilt. Now they build a couple others that are smaller. I think they're rebuilding these. No. It's the 1500J or something that they rebuilt. That's the smallest one. This is the smallest commercial that we can get. It's literally cheaper to put this $800 tube in place of this $1,600 tube. Because brand new from Richardson's, these are about 1,600 bucks. Not the Russian copy, but when you've got this big of a cabinet, like what we had before, it only makes sense to go ahead and go to a bigger tube. Just saying. Well, it's about that time where I take this tube and I bolt it in this deck. That's the reason this is out on Front Street too. Because I need to get this out. The tube needs to go in, the tube needs to get bolted down, and it's time for us to start working on the bottom side of the deck, because the top side of the deck is about 99% done. So, still yet to come is a 12-volt power supply to run the relays. Input network, relays, filament, and filament chokes. For this guy. So, it's time. It's time for us to crack the seal. That thing sure is pretty. They're only new once. They're only new once. Now, I like to wear the gloves because the silver plated tubes, any kind of oil that's on the tube, when you touch it with your hand, it's there forever. And this thing is without a scuff, without a rub. I bought this, me personally, I picked this tube up in Woodland, California when I was down there. I bought that from them. And that rode home in the back of my Tahoe from Woodland last year, specifically for this project. Specifically for this project. So let's set this out of the way where it's not going to get knocked over. And let's go get it bolted in the deck. Well, cruising right along here, we've installed ourselves a little switching power supply here. What this power supply does is allows us to power our relay, which is here. Okay. And also what it's going to allow us to do is power our fan. So we have the blower that takes care of the top side of the box, which cools the anode of the tube. So now we have to cool the filament side. So this is our actual tube that's now been installed. Rotate this around for your viewing pleasure. This is our actual tube and our aftermarket RF junk made socket. These are our filament chokes. Now there's a really simple principle that takes place here. We gotta block the RF, okay? So our RF is gonna come from our PIL network, come down and go through this coax. There's this giant 0.01 disc capacitor that is gonna isolate this circuit from this circuit. Okay, that's what allows us to keep the 7.5 volt, 55 amps worth of current from trying to find its way back out into your radio or any other electronic device that you hook up to this. This is called your blocker. Okay, it's blocking. Now, really all it's going to do is cause isolation, because the AC can pass through this if it wanted to. It's a capacitor, right? So we have to keep the RF, the genie, inside the bottle, and we have to isolate our filament transformer. How do we do that? There's several different ways. On the bottom of, let's say, like an SP220, you have an inductor winding, two pieces of, oh man, worse, coated wire that it's a lacquer coated wire that we wrap around a ferrite rod, piece of ferrous material, usually type 61 or type 43 material. Okay, well, that 55 amps is a little bit too much for those little tiny wires to carry efficiently. So what we figured out is that you don't even need a piece of ferrous material as long as you're only working in one band. You can tune this circuit so that it chokes out all the RF for one specific frequency. Now buried back up in here, up off the wall, is a 1000 puff 7 kV capacitor that comes off the end of this coil, this inductor coil, and this inductor coil. Please note they're not the same length. That's in by design. You don't want these two wires to be resonant to each other in any way. Normally what people will do is they'll wrap this around a piece of ferrous material and the wires will almost touch, which makes them inherently very poor RF conductors. So we want to be able to keep that transformer isolated. I've had several friends over the years where they had their filament transformers in the RF deck, which I think is a shit design, by the way, in my opinion, and I think the builders that build like that need to reevaluate their universe. They'll actually put the RF filament transformer inside the RF deck and then never build a shield around the transformer. So all the RF that's getting produced by the tube can then itself, through the tuned body or tuned cavity effect, transfer itself onto the transformer, and then it's going to double inject itself back into your filaments. Makes it kind of a closed loop system. RF goes out the tube, gets inducted onto the filament transformer, and then injected back into the tube. Me personally, I like to separate the two units myself. The filament sits outside of the RF deck, that way it's completely isolated, and then we want to completely choke that off by not even giving the RF the opportunity that we're feeding into it to go out. Thus, also creating the situation, any RF that might be on the outside can't come in because it's not resonant. But you can do that with just a straight line of inductor coil. Basically the same thing is taking place on your filament choke and your glitch choke. Two non-resonant turns of wire that anything else, like let's say if we have a problem, it's going to go directly to, that's the glitch choke, it's going to go directly to ground. But your filament choke, or your plate choke, is to conduct the high voltage, but then keep the RF on the tube and not let it follow that wire and go out the deck. Same thing is going on here. So over here is 12 turns, over here is 13 turns. They are separated just slightly. The coil separation is a little bit. I wanted to make this one intentionally longer so I could make it lead around, and we got a nice smooth connection over to the top of the tube. We took some cut Teflon because these wires will get fairly hot. This tube, as it runs, because this is basically the bottom side of the light bulb, this thing will get to be a couple hundred degrees, probably 130, 140 degrees. So these are soldered connections, but we have to create an air movement path for us to be able to put air in here to cool the bottom side of the tube. Now, how most guys do this is they'll pressurize the bottom side of the deck. They'll put 5 or 6 little holes around the anode, force air straight up, catch it with the chimney, force the air through the chimney, and then leave the top portion of the deck unpressurized, and it just kind of bubbles out however it's going to come out. I don't like doing that. I like putting the chimney to the lid, having the blower be its own separate thing for the anode, cool the tank coil, cool all the other parts inside the deck. This is going to be a very low output box. We're not going to be coming anywhere near to the tube's maximum amount of output power. So it's not like the Demon or the Exorcist where I had to put big blowers on everything, and we're not going for broke. We're going for a slow cruiser, right? But I did the same thing with the Demon and the Exorcist. They've got little fans, like we've got here, that push air in, and then we control its pathway on its way out. Air comes in, tumbles around the inside of the cabinet, and exits out the back, but it's got to cross over all of these connections to get out. That's the goal. So let's go ahead, let's fire this up. This is what I call a benchmark moment. I'm really happy. When I get to this point, I know I'm almost done. The only thing I got to do is add a RCA jack, which will probably go somewhere in here. Don't know yet. And that's for our foot pedal. And then I got to run a piece of coax from the relay, a piece of wire from the coax connector, so a piece of coax from the relay over to our first tuner, then to our tuner, then out to our tube. We've already got that entire circuit. So pretty quick, I'm going to be able to look at the input tune network, and then we'll go and we'll play with that coil that's on the inside. That's the whole box running right there. Stealth mode, baby. Blower is turning. Our little 40 CFM, 50 CFM fan here is turning. And we got ourselves a nice smooth jet of air coming out of the back. It does not really take a lot to keep the filament leads cool, but we do have to have airflow across the bottom side of this deck. We do. We do. I get this done, then it's on to all the heavy lifting. That's where we're going to go do the power supply, add the filament transformer, add our bias board, which I've already got built. It's around here someplace. Our new supplied to us by RF Junk. Says so right there at the top. rfjunk.com bias board. We're going to end up somewhere down in this string, somewhere right in here, for our zero signal. But because we got such low plate volts on this particular application, there was no need to populate the whole board because we were never going to get up that high. Just, it's not going to happen. Now, if he goes and he decides he wants to do a different plate transformer and turn this thing to 11, there's a couple other parts that we'd like to change, so we could come back and we'd have to repopulate this fully. But for the most part, that's going to get us to go. Oh, all right, so this makes me super excited to get this far. It means we're almost done. This is one of the last things I like to do. So we'll put rubber feet on here so it can pull fresh air in from the front side of the cabinet. A little bit of hot air is going to come out the back. We've got our blower down here, squirreling away underneath full back pressure, which isn't the best for the blower. So we'll lift that up so we can get some full air movement. That's it, that's it, that's it running right there. Short of transformer noise, that's all we've got to worry about. This will be a switchless box. The power supply cabinet is going to be having all the switches on it. It's going to have the on-off and the filament switches and all that stuff. This will turn on and off with the filament. Stand 110 volt plug. So as soon as you turn the filament on, it's going to bring on the blower. You're going to bring on the filament fan. These have to run. These two units have to run as soon as the filament's on. There's no way around that. And this had the dumbest switch of them all. It had an operate standby switch. And I'm like, wait a minute, it's foot pedal driven. If you want to be in standby, just don't step on the pedal. So we're going to eliminate that one switch. Okay, moving on. Okay. So we're looking at our input tune now. And we're looking at the input reflect. All right, so the lower we go in the dip, the lower our swirls are, okay? So right now on channel 44, that's where the red marker's at, indicated up here. Let me spin this monitor around so I can see what I'm doing here. This little red dip here indicates that we're on channel 44, 27.44722 megahertz. 1.009, which is really good. Okay. Now, that green marker, boop, is some down there around channel 1-ish. So, with very small input adjustments. Oop, overshot it. Back it up. Back it up. Beep, 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 beep. That's pretty good. So that's the whole spectrum, back and forth, of where this thing's going to probably end up getting used. I don't know. I'm just saying. So, needless to say, we are literally talking about, back this up, like a pubic hair worth of adjustment to about here and to about here. Those knobs. Very small, but very flat response. So we know we got our input tune good. These two knobs do their job. Okay, now let's look at the pass-through tune. I'm going to have to add some caps and bring the dummy load into play and bypass some relays and some shit. Okay, so now we're going to look at the pass-through SWR. And what do we mean by that? We mean for the ability for the RF to go from this meter down this coax through the box and out to the antenna. Now, the main thing that we're looking at is our bypass capability. What do you mean by bypass capability? I mean, if the amp isn't in operation, you're going to be talking through it. So you want it to be able to pass your signal for your antenna to your receiver, and for you to be able to transmit through this on lower power, right? So let's go over here and look at the unit. The unit. We are, I think, 58 kcs wide at the moment. So what are we here? We are from 0. Yeah. 0 to 51 kcs, 51 megahertz, pardon me, not kcs, 51 megahertz. So survey says, pow. Not teabag. 1.2. Now remember, this is going to fluctuate as soon as we put the lid on it. So I can put my hand in here and it changes stuff just by its presence. This gets us down to a 1.0. So we're not, that's really actually quite good. It's really actually quite good. Just check it out all. Literally just by putting my hand over the top of the relay, changes it, drives it down. And where we're looking is right here. Actually, we're looking right about there. So 1.0 whatever. Pretty good. Actually really good. Okay, now let's go emulate load and look at the output load resonance. Okay, so we've emulated load, we've closed our relay, and now we're looking at the output coax connector. But we've got our network analyzer hooked up to our output coax connector, and we're looking back into the RF deck. And what we're looking at is the signal coming in, coming up to this tuner, which is tuning to the outside world, going through our inductor circuit, which is tuned for frequency, and then we're looking at our capacitor through our blocker back to the resonant portion of the tube, the anode, okay? So let's go over here and let's look at frequency. We're starting at 26.491667. And the red indicator is basically channel 49, 27.49. 66666. Okay. So right now we're at a 1 point. Let's walk that on over there. One point zero zero 5. See how low can we get it to go? No, it's going up. It's going up. Oh. Oh, I've spent hours totally farting around with things like this. Just remember, I spent 3 days one time totally farting around with the deck that was I converted into the 40. I initially had a 50, and I spent 3 days totally farting around with that deck circuit. Got nowhere. I was like 0.220. It was ridiculous the amount I shaved off it, but man, that thing sure runs like a Swiss watch. Okay. So anyhow, what we're looking at is this lower marker. 26 megahertz, that's where our dip is at, and we're seeing how low we can get this to go just for fun. 1.05 is the lowest we were able to achieve. 1.005, pardon me. I mean, nothing is 1.0043. I'm leaving it. That's tight. All right, so now by twisting of these two knobs, come on, there we go. If I can achieve a perfectly resonant dip at one end of the band and another perfectly resonant dip at the other end of the band, we all know that it can be found anywhere in between as well. Get on down there. We're splitting angel hairs now. There's 6, 5, 4, 3, 0, 2, 1, 0. Nope. Don't make anybody breathe. We might get it. Okay, I'll quit wasting your all's time. I'm sitting here fiddly farting around. I want 1.0000 and it's not going to happen. 1.001 is about as low as theoretically we're ever going to get. Needless to say, our frequency dip is perfectly... Whoa, whoa, whoa. Stop touching it, BBI. You're making for bad video. Stop. Stop it. Stop it. Okay. I'll quit wasting everybody else's time. I really take pleasure in this portion of the tune. I really do. Because this is where the rubber hits the road. If your tank circuit ain't right, the RF poop can't come out the tube, can't hit the coax connector, can't go to the resonant transmitting and pour in all directions antenna. It just don't happen. This, short of the RCA connector, which I've got a whole bag of them and I can't find one at the moment. This deck is now done. Tested, completed, done. Moving on to power supply. Whoop, whoop. So here we are with what's left of the power supply. Now the only damage to this cabinet all the way around on this unit is a dent in the back. So we are going to pull this dent out and square this up again. We're going to come back to that. But what we got here is a fun little bit. Oh, ow, 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 sharp. Okay. This is the brand new EPD filament transformer I ordered for this. And there's no data tag on it. But we'll figure it out. Let's see, what does it say on the paperwork here? Should be 7.5 volt at 55 amp, and then I got it set for taps at 110, 120, and 330. 7.5 volt, 55 amp, continuous duty. CCS. That's it. This is for another project. This is an SB220 replacement transformer. I believe this is going to go into 819, 815, something like that. 8 something or other box that I've got over here that the plate transformer exploded on a couple months ago. Well, let's get this dug off this wood. I got it out of the box. That's the only part you guys didn't get to see. And I got to figure out where I can mount it in here after I get the plate transformer installed back in here. And the only thing I need to do is relocate over to this amplifier, this portion of the amplifier, the on-off switch and the standby and operate switch, which we're going to all do from here. This pin here on the back, we're going to change this out to the foot pedal hookup for the amp. So it's going to loop in one and come out the other. So we'll have the RCA jack on the amp deck for us to plug our foot pedal into, and then that same send signal is going to come out over to here to kick another relay for us to be able to go to center tap and for us to grab our bias board. Let's get this off the board. I'm going to put a label on this, but we've got our high voltage indicator tested and recertified. Power supply board is remounted, and that's all fixed. Our glitch circuit is recertified. Our bleeder circuit is fully tested. Went ahead and added a filament transformer here to the front of the deck, just because sheer convenience. Got this set up so that we can loosen up this Heiko connector. You just push one wire through at a time. I got this set up on a slip connect over here. If you want to focus where I'm actually pointing camera, that'd be freaking amazing. Don't ever buy a studio camera for shooting this kind of stuff, by the way, you guys, because its field of focus is about this deep. But what's in focus is razor sharp. Everything else is blurry. It drives me nuts. Got our controls in here to fire our bias relay. So bias relay will click in and engage our bias board. And got our high voltage board remounted and that all fixed. Replaced our soft start resistor because it was cracked and broken. Thank God, out of all of that stuff that I just tested, or all those resistors I just went through for that 3cx800 box, I was able to find another giant 300 watt 15 ohm resistor. But got our contacts fixed over here. Had a couple leads that had popped off of there. Got our 12 volt soft start timer in. Got our time off timer installed. Here on the back we got our jumpers for our communication cables from the amp deck. This carries a 12 volt positive current from the power supply on the amp deck. It carries a ground signal from the foot pedal to key the bias transistor, or transistor. It's been a busy day. This little is our key circuit for our bias relay, our high volt lead, filament transformer, and 110 volts out for power supply and fans. So that's that. This is all wired up and ready to go, tested, and all left to do is throw the lid on it and dry run it, which means probably putting this thing in a sock and watching everything turn on and making sure all of our timers work. So that will be tomorrow. This is about 99% done. Put the lid on it and we'll start marrying it up to the amp deck. Yay! Woo, BBI! Yay! Well, back over on the amp deck, this is all done. We got our plugs all married up for our bias switch, 12 volt supply, and then our key return. We've got our foot pedal all hooked up over here. So now all we got to do is slap the bottom on it. That's for your foot pedal. And we need to get this thing cooking because it's got to sit and run for a while. When I went on the grand tour to Conco, I asked their head engineer down there, one of the questions I asked him is, well, how long do I need to run the tube after it's been sitting or I've received it from manufacturer from you guys for outgassing of the tube? And he goes, oh, not very long. I don't think so. I said, oh, okay. Well, me personally, I listen to my elders that come before me and lots of different things. And they all insist that you need to cook the tube in for a little bit before you apply high voltage. And it kind of makes sense. It's to help cook gas out of the tube and let the filament stabilize and all that stuff. So we are going to slap the bottom on this thing. And then I'm going to marry it up to the power supply, which has changed since the last version of it that you guys seen. Over here, it's now got two locked on target missile rocker switches on it. I got to thinking about it and I wanted to separate out the high voltage and the filament and not make it all auto start. So this is the master on switch. which will turn on all the fans and the blowers and stuff and get this portion of the box going. And that's all it does, really. That, and it's the primary breaker to the outside world, kind of like how Henry used to do it. Not a big fan of that, but that's how this has got to be set up. We ran out of space on the inside of this, period. So, and you bring your filament on, and when you bring your high voltage on, now that the inside of this cabinet is going to start to produce heat, it kicks on this fan as well. It's got a 15-second time-on timer that allows the high voltage circuit to kick on, and then it brings on the soft start circuit, which is about 3 seconds. So it's almost all instant, but 20 seconds from flipping this switch up, 20 seconds from flipping this switch up, good to go. And down is off on everything. So let me get some feet put on this thing, and let's start the cook-in process. This right here scares the shit out of me, and I'm not a fan of this. If it was up to me, we'd do this whole different thing. We'd do it all in one enclosed box. But this is what the customer wants, built on the platform that he wants. So here it is. 110 volt hooked up. Our filaments are hooked up. That's these leads here. Our ground is hooked up. Our 12 volt remote for our bias switch, that's all hooked up. So let's spin this thing around and let's turn it on for the very first time. Got good air cooling around the filaments. Filaments are on. So we have the filament transformer set on the highest primary voltage, which is, I think, 130, which is good. And we're pulling 48.9 amps, which is good. And we are a half a volt low, so it means all I got to do is go in there and change the tap setting on it, and we'll get it up to 7.5. But everything's working. So now it's got to sit here and run for, I let this run for at least 4 hours, maybe 5. Oh yes, tube's starting to heat up now. It's exactly what we want. As the filament settles in, this filament amperage is going to settle. The voltage is nice and steady. Oh yeah, the tube's at 87 degrees air. Ambient room temperature is 73, 75, somewhere near 73 degrees. So, blower's sucking in 73 degree air. No, I'm happy. This whole setup makes me happy. Very low volts. When I tested the high voltage circuit, it was putting out 3,500 volts float at the top, which will really neuter this tube, but the tube will last forever. I mean, like, it'd be like that old boy with the pair of 800s. We get 20-something years of use out of this thing. You know, put a couple hundred watts worth of drive in it, and this thing's going to run, you know. Run, and run. Filament leads aren't getting hot. They're at 77 degrees. Ambient air is 72, 73. Yeah, the leads are 80 degrees. Our filament's starting to settle here. This is good. This is all really, really, really good. I'm happy. Well, this is the way this gets to sit now for hours. Just going to sit here and let it run. I'll come out and check on it probably every half hour for about the first 2 hours, and then I'm just going to let it sit here and cook. So very busy in the back here. This whole corner over here is just very busy. But yeah. Okay. Let's let it sit and run for a while. No big deal. So here we are many hours later, and what we got going on is 7.46 volts, which is as close as we're going to get. It's pretty damn close to 7.5. And we're pulling 51 amps worth of filament current. So now what we're going to do is we're going to set our bias point. So let's readjust this for DC. We're going to 0 DC, 0. Set that kind of cockeyed up there. So how we adjust the bias point on this is by taking diodes out of this string. And I knew I was way overshooting on our string of diodes. We're currently on this one here. We started out in the middle row, but now we're on this outside row. So we got 1, 2, 3, 4, 5, 6, 7 diodes in. Of course, remember our plate voltage is only 3,500 volts, so way low. We're reading for that to read 2 is what we're looking for. Okay. 0. .02 or 0.20. So 200 mils. Actually works out to be about 250 mils, but it's at the very bottom end of class AB1, which is what we want to pull all the heat out of the tube for operation. Okay, power supply works, relays work, bias circuit's working. Everything's working. Everything. Yay! Whoop whoop! I'm really excited. I'm here to tell you. If you can't tell, I'm just overwhelmed with joy. Set. Quiet on the set. Okay, ready? Action. The clacker board's actually really important, you guys. We'll pause on this for your review later. Okay. So the reason the clacker board has to come into play is I got too many damn videos going on at too many different times, and I'm starting to lose track of what's on what, and I'm utilizing multiple cameras. So the little clack action and then the physical action of it moving is really important. I noticed in a couple of my videos I've got my time sinks. Just, it's like, here's the action, then the sound. So you get the time sync just right. I hope you guys appreciated the humor on the board. Remember, it's the making of you, co-starring your Uncle Ron. Okay, so what we've got here, and I cannot express to you the level of excitement that I have for this point in the video. And let me explain to you guys why. I have tried to shoot this same segment of video now 5 times today, and every single time my phone rang or the company phone rang. One of my bosses is out of town doing his hunting trip, left me with the phones, kind of managing the drivers a little bit, just kind of answering the phones and directing the show. So that phone would ring, I had to answer it. Hence the reason it has taken me See when I come out here this morning, 7:30, and it is now 8 o'clock at night. So it has taken me 12 and a half hours to be able to shoot one segment of video. So I'm ready. Let's show you our different camera views. First camera view is the big camera here, and then our second camera view is this little guy here. So let's switch over to that. Now over on the little camera, what we're looking at is our bird meters. And let's go ahead and we'll show you what each one of the elements are. So this is a 50 watt element. Whoa, 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 whoa. It's been a while since I used this camera. 50 watt element in reverse between the outside world, which will be the 4-pill, and the derail. I can pan up that far. Derail 955 up there. So the output of this, how do I lock that tripod down there? The output of this, it's this side of the meter by the way, goes directly into the 3000. Now this is a 50 watt slug in reverse, and we're going to go over here and we're going to start out at our 1000 watt slug in peak to start with, 10,000 watt slug in RMS, and a 5 watt slug in reverse back from the bird 10,000 watt dummy load. So let's get this framed in. Like I said, it has been a long time since I used this camera manually. So let's get ourselves even a little bit tighter. Make it easier for you guys to see the needles dancing around. Okay, now what's really important, let's switch back up to the big camera, is that everybody can see what's going on here. Okay. Hello, 1, 2, 3, 4, 5. Okay, everybody can see what's going on. It's really important that we show what's going on all the time with this kind of deal. That way the naysayers can't punch too many holes in whatever I've got to say. Or they can, I don't care. But I want everybody to be able to see how we tune everything here. So my theory of thought is that we tune for maximum peak power. That's based off of every measurement in the book. Grid meter, plate amperes, watching the volt sag, watt production, the heating of the tube, and the heating of the circuit. Okay? Peak power is the most efficient at all of those things. So when I hear people say to me, and people are entitled to their opinions, it's the beauty of living in this country, no one's going to come along and say, you can't think this way. I tune for peak power, and I am going to show you peak power, period. And we're also going to show you huge carriers. Well, as much as we can achieve with 3800 volts on the plate. Let us not forget that this power supply had a matching amp deck, and the only thing in that amp deck was this little 8877 tube, otherwise known as a 3cx1500a7. Okay? A little tiny tube in this big box. Now we got a great big giant tube in this box. The difference is the giant tube costs $899, and the little tiny hockey puck tube now costs like $1,800, at least at the time of shooting this video. So now the cabinet actually matches the tube. It'll be like Vanna White. Okay, so let's go ahead and get this dog and pony show started. First switch up, all that really does is turns on the 220 and it starts our fans. All our fans. There's no way to run this box without the fans running. It's just not possible. And it's there for safety. And we're going to click on our filaments. Our filaments are now live. Now with the 3000, they're instant on, which means ready, go. Okay, let's go talk on it. I like to give myself a couple seconds, so I'll kick the filaments on. 1, 2, 3, 4, 5. Or you kick on the high voltage. Ready? Click. One more click. Now we're ready to talk. It's all about the soft start circuit and how it works. Okay. So we're ready to go. I have the box all tuned up for the driver and all tuned up for the derail radio. Now I need to pan up the big camera just a wee little bit more, and I want to point out to you the side of the derail radio. We have two adjustments knobs up here. All right, the one in the front is variable peak and the one on the back is variable RMS. Variable RMS, yes. Everybody's like, RMS is fixed in stone. No, it's not. No, it's not. And the amplifier has nothing to do with RMS. Never has, never will, never, ever is going to ever. No. Okay, I hate people that are like, but if I know the RMS number, I can calculate the peak number. Nope. No, you can't. The only thing that's a universal constant at this point that is a fixed unit of measure for us to play with now is, well, peak. Now that our friends down there at Wolfman CB Shop, by the way, D-Rail's got his own YouTube channel. You guys might want to go check it out. Now that our friends down there at Wolfman CB Shop and everybody else in the country's tried to figure this out too, he can make that radio do anything your heart desires. Your average numbers all are derived from how the signal works coming out of your radio. All your amplifier does is amplify more of whatever you put into it. This is a fact. This isn't anything that is open for debate. You can believe whatever you want. At the end of the day, the facts are the facts, the truth is the truth, and this is what it is. Okay? So I'm going to reach up here and we're going to show you on these meters down here with this box how that average number is just a variable now. It's something that we can make read anything we want. So first things first, last things third, third things fifth. Let's go ahead and get ourselves a little bit of a meter measurement, a little bit of meter measurement. Let's jump down here to the small camera. Okay, peak kits on. Hello, 1 2 1 2 1 2 1 2. Put something a little bit heavy up there. I don't want to listen to that thing rattle the whole time I shoot this video. That'll work. I've only got like 3 or 4 screws holding the lid on at the moment. You never know, you might need to get in there and stick your fingers into it. Not while it's hot, of course, but. So, we're on a 1,000 watt scale. We'll step on our pedal, spike our mic. Hello. Making about 700. Hello. 750 watts. That's all we're making. With about 80 to 90 watts worth of drive. Let's go up here, turn our mic gain all the way up, and make sure our variable power is all the way up. You know what? For sense sake, do I have the 10,000 in there? I don't. That's a 1,000 watt slug. So let's go back and reshoot that same thing. Turn the variable peak number all the way down. Hello, audio. So we're showing over here about 750 watts. Hello, audio. Hello, audio. And then right here, we're showing a whole whopping, hello, 100 watts. Just where everybody in Radio Land's going, oh my God, that amp's crap, it's crap. Let's click over to the big camera. Click up the variable bird watt number drive knobby. Hello. Let's click back down to the small camera. Hello. 700 watts of peak. Hello. See what we picked up for bird? Hello. We doubled, almost tripled our bird output by the turn of a knob. Okay, back to the big camera. Let's go ahead and we're going to turn our RMS numbers all the way down. Hello, 1 2 1 2. Hello, 1 2 1 2. Back down to the little camera. Hello, 1 2 1 2 1 2. Okay, now that we've established that the average number is a variable, is no longer fixed in stone. See, these guys back in the day, they'd hook you up with a really hot radio that had a really, really good AM audio injection. And so everybody would be like, well, my average numbers are way higher than yours. So this is a great shootout radio. No, it's just got more audio added to the AM section of the amp, or the audio circuit in the radio. Okay, so without stepping on the foot pedal, let's go back to the small camera. Hello, 1 2. Hello, 1 2. Hello, 1 2. What I'm showing you now is drive out of the 4-pill. So just the 4-pill, not stepping on the pedal. Hello, 1 2 1 2 1 2. Getting about 800 out of it. Back to the big camera. Let's turn our variable RMS knob back down to the small camera. Hello, audio. Hello, audio. So now we're making 300 bird and about 800 peak. All with the turn of a knob. Back up to the big camera. Okay. Back down to the little camera. Hello, audio, 1, 2, audio. So we lost about 125 bird by turning the knob down. Please note, the peak number stayed exactly the same. Freaking cool, right? Okay, so now I know for a fact we're going to go to 2x. Step on the pedal. Hello, goodbye. Okay, disappeared. Now we're going to go down to 5x. So this meter here is reading now 5,000 peak watts. Hello, goodbye. Hello, goodbye. Hello. So we're making over 5,000 watts peak. Hello, goodbye. And about 700 bird. Now let's watch this. Turn that variable RMS number up. Goodbye. Hello. So we're laying everything in the corner now, all the way in the corner. Turn the peak kit back to 1x. We're going to pull our 1,000 watt element out. Better leave it up here on camera where everybody can see it. Put our 5,000 watt in that hole, and then we'll put our 10,000 watt in that hole. This scale here, we're reading the middle scale. This scale here, we're reading the bottom scale. All right. Here's our driver. Hello, audio, 1, 2. Hello, audio, 1, 2. Big box. Hello, audio, 1, 2. Making about 2,200 bird here. Hello. And we're laying the peak meter over on the stop peg again. So now, let me reach in here. We'll go to 2x. So now we have 10,000 watts peak and a 10,000 watt on average. Hello, 1, 2, 1, 2. Hello. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Okay. Everybody out there in radio land's yawning right now. They're like, oh my God, it's a 3,000. It only makes 6,000 peak watts. That's garbage, and he's having to drive the crap out of it. Wrong. What we have is a 3cx3000 with 3,500 volts on the plate, instead of the 5,000 or 6,000 volts that we'd want to have under load. We have 3,500 volts. So full 2,000 volts less than what we would ideally want to have for optimal operation conditions. It is amazing the amount of power difference between in that 2,000 volts on the plate. Back to the big camera. Let us not forget this power supply, the transformer that is in there, was initially designed to run one of these. Now, with that being said, I can tell you the way the box was laid out. It was designed with the idea in mind that we could put a couple of these in that amp deck. Just because the way the amp deck was laid out, and the transformer was definitely big enough. So when I saw how big the power supply was, the transformer that was in here, I went, we can run a 3,000 on it. Now, the 1,500 tube that was in here was not bad. I don't know where it's at in its life. Being that it's like 10 years old and been in operation, I wouldn't say that it's 100% output, but it's still very high. The last video I had it on, it was doing a full output. But the guy that owns this amp, he wanted to be able to have longer talk time, and he wanted to be able to have a tube that was rebuildable. It's 3,000 all day long. Is this thing built for megawatts? Hell no. Hell no. So nobody can dog Wizard for anything. What Wizard built worked. It blew up after a long time of use because, well, all the oil came out of the oil-filled capacitor in it. That's when it came here, because he couldn't get a hold of Wizard. I rebuilt it. We put it in the mail. UPS smashed it. Came back. Now we're building it into this. Bet your balls it's going to go home in a frickin' wood crate. Okay. Let's take a minute and let's look at input reflect. Tighten. Yeah. Tighten in. Tighten in. All right. So we have some kind of frame of reference. That's our 10,000 watt in average. There's our 50 watt slug in reverse. First, I'm going to drive it with the radio. Step on the pedal. Hit 1 2 1 2 1 2. Doesn't even move, does it, guys? All right, so let's hit it with the straight 4-pill. Hit 1 2 1 2 1 2. Hit 1 2. Hit 1 2 1 2. Hit Back to the big camera. Look at where these two knobs are set. These knobs turn in 360 degrees, but they only interact with each other in certain planes. There is no reason why you should have any kind of input reflect whatsoever. The way this network is set up in here, between the moving of these two knobs, you can dial in anything. But I want to show you something. Let's go back down and look at the... Let me take a piece of tape. Before we go back down to this meter, we take this piece of tape and we're going to put it in line with this mark. It's roughly in line with the mark on the knob. Let's go down to the reflect meter here. Just pull up a little bit of carrier here. There's about 500 watts or so, I think. Look at how far out our reflect is. That's about 50 watts worth of reflect. Let's go back to the big camera. Let's just see how far out, how little we had to move this knob. All the way back to 0 where we started from. You see that? See how small I had to make this adjustment? There's 50 watts input reflect. It's pretty close to 0. That's about a half a watt. See how little amount of movement we have to put into these? Very small amount of adjustments. Everybody always wants to get in here and they start just twisting. Man, it won't tune in. I don't understand why it won't tune in. I don't understand it. I can't find it. There's something totally wrong. It's, oh my God, there's something totally wrong. No, it comes down to the operator. Zero input reflect. You want nothing coming out. You all want it going in the tube. So now we've established that. Let's go talk about these tuners. These are vacuum variables. These tuners down here have plates that move past each other. These are air variables. This is a vacuum variable. So it's got a bellows system and a set of circular fins that go in and out of each other inside of a vacuum body. Once again, very small movement. One turn, two turns, and now we're at the very bottom of the tuner. See this? The very bottom, we can't go any further. So if you ever get yourself too far out of whack on your output tune, right now we're tuned for the middle of the band, take you and you're going to turn it clockwise, 1.5, 2.5 turns off a bottom. That's pretty much where we want to be. So 2.5 full turns off of bottom. Bottom is clockwise, removing capacitance, or bottom is counterclockwise, removing capacitance is clockwise. So adding, counterclockwise, removing, clockwise. And the same thing with this. although this one's in the middle of its movement. So you're going to have to make counts. You're going to have to make a count, turn the knob, and count that we can find top and bottom. I'm going to send this with tape on the knobs, and we're going to put pallet wrap around it. There's no way these knobs are going to be able to be moved out of tune. So once you get it, it will be in tune or fairly close to it, at least for your setup. It might be a pubic hair this direction, a pubic hair this direction, an angel pubic hair here, and another angel pubic hair here when you get it on your end, John. But this is exactly what you wanted. Now, let's go back over to the little camera. Let's widen back out on it. And let's go down here. Come on, let's go. Okay. I'm going to take that down to 1x. We're going to put, it's our maximum dead key here. That's all she's going to give us. Audio. Remember, we're on a 5,000 watt slug. So we're putting, what does that look like on camera to you guys? About 300 watts into it. So, audio. Yeah. Showing us the same thing on both meters. About 2,200 watts. And it's still trying to go forward. So it means technically we could still put more drive in it. We're starting to run out of plate volts. As you guys can see, on this meter, we're not running it off the scale anymore. It's running out of gas at about 5,500 watts. Of course, we're now pulling, we're at 3,000 plate volts. But we're stiff at 3,000 plate. Plate voltage is barely backing up. 1 2 1 2 1 2. Just trying to run off the scale. 1 2 1 2. Now, my teacher, old Prime Minister in the corner, the host with the most, he always told me the guys will not pay attention to what you built unless you throw a big DC and hold it there for a while. I wonder what will melt down first. I wonder if it'll be my 4-pill, or I wonder if it'll be the tube amplifier. Let's take and fire up our FLIR, our E6 FLIR. Kind of starter kit FLIR here. See our exhaust air temperature coming out of there right now is about a 153, 135. $159. So we've been running it good. Wow, you guys should see that. I'm going to take a picture of this. That thing that looks like a hot spaghetti noodle. That's the coax coming out of the bird meters. I take a picture of the dummy load. Let's look at the 393 going in. You guys are going to love the picture quality on this thing, by the way. Couldn't believe how hot this was. Looks like a friggin' lightsaber coming out of the end of the bird meter. Okay, where are we at up here? Where are we down to? We're down to 135. You guys are going to have a bunch of pretty pictures to look at. I'll make sure to throw these in the video. The other thing that this does really well is because the screen's bigger, you can translate a little bit more over to the camera. A little bit more over to the camera. Does this translate any better? Nope, because the camera can't focus that close. You'll see. I'll show you on video. So, what are we down to? We're down to 115 degrees. So, should we go for a big dead key? 2,500 watts. Okay. Let me add another driver. So, I brought in the bench 2 pill, and I'm on the striker radio, or my RCI now, because I didn't want to take a chance of overloading the 2 pill. And let's do like we did before. Let's go ahead and hop down to the little camera. Nothing else has changed. It's still the 5,000 watt slug over there on the right. And peak, even though we're not going to modulate, and then this 10,000 watt slug right there. I'm a little leery to take this over $5,000, you guys. I'm not going to lie, and it's simply because I know that I'm having to throw over 1,000 watt carrier out of 4 transistors, which is bad. So we're going to just key this. Let's see, that's 2,000 watt, 3,000 watt, 4,000 watt. Right at about 5,000 carrier, 4,500 somewhere in there. Back this up to $4,000. We're just going to hold it here for a minute. Big camera real quick. We're at 3,000 volts here, 3,000 volts here. Back to little camera. Let's dial down our input. 0, literally 0 on the reflect. 4,000 watts, 4,000 watts. So 4,000 and 4,000. And I'm more worried about my pill boxes than I am this tube box. Back to the big camera. Very clearly what's going on. Back to little camera. I'm going to unkey before I blow up one of my drivers. And for the record, that was literally an 850 watt dead key that we're throwing with a 4 pill. Continuous. Check it out. Remember, or no, what am I saying? 400 watt dead key. A 5,000 watt scale. So we're making just short of 400 watt dead key. Okay. Yeah, that makes sense. Yeah, well, I'm still more worried about my driver than in this big box. 4,000 watts. Pink, no problem. Let's max it out. Screw it. There's $5,000. It's holding it. And that's out of 3,000 volts on the plate. So, well, guys, that's it. Got nothing more to really brag about. This is a lot of fun. This is a fun build. This guy let me build this in my own time. It took me forever, but I like when I get projects that are built in my own time and I'm not underneath a timeline and I'm not underneath any pressure. So this is one of the ones that had to get finished. It's just been takes up too much room, is taking too long. So got this one done and in the done pile permanently. So tomorrow I get to shoot a whole nother video on this thing, and that's how to disassemble it, because remember, tubes got to come out, filament transformers got to come out, plate transformers got to come out. Then this is all going to get final assembled. That means I need to fill the inside of this full of packing material. The inside of this full of packing material, I got to build styrofoam supports for the back of the vacuum tuners. Styrofoam supports for the blocking circuit. Styrofoam supports for... I got my work cut out for me tomorrow. So that way the guy's got a video on his end to go, okay, now what wires go where? He's got a physical, visual demonstration on how to put it all back together on his end. You dare not ship one of these with the transformers in it. It just turned into a pile of wadded up goo on the other end. Well, gentlemen, I have had almost 300 phone calls today. None of them were amp related. Well, most of them weren't amp related. It's been a very busy day. I'm starting to lose my voice, and I'm getting really tired of hearing myself talk. I appreciate y'all tuning in. Believe me when I tell you, there is more porn coming. This is a never-ending stream from this point forward, between now and, well, about the middle of December. So hold on, buckle up, buckaroo, because shit is about to get real. I appreciate every single one of you guys. I will see you. I mean that from the bottom of my heart. I appreciate you guys more than you absolutely even know. I will see you. Bye.